record on this computer, and then share screen. All right, so as I said, everyone, that we're wanting to open all three scripts. So this is structural steel sweep, the one we did before the semester or before spring break. We want to open the white flange script, and we want to open the hollow structural section script. The structural sweep script, you see that I just kind of reorganized it and tidied it up. So if yours looks a little bit different than mine, I wouldn't panic. It just, I reorganized it. You can like take a screenshot of this right now and reorganize yours the same way. I'm also thinking about, and I haven't decided yet, but I'm thinking about sharing a high resolution screenshot of my script with you all instead of just sharing the script as I usually have done in the past. So we'll cross that bridge when we get to it. For now, we want to start prepare an export of the data coming out of the white flange and the hollow structural section family or scripts. All right, so let's see if this thing is still working. I always like to QC my stuff, or quality control. That's what QC means. I did not know what QC was until I started working professionally. So. All right, so let's see. I did find one small error. It wasn't giving me, like it wasn't throwing an error, but I hovered over this output of my joint curve component, and it told me that there is 246,051 curves, and I was like, well, that's clearly not correct. So there's something wrong here, and I kind of went through it, and I figured out that this here is taking in 351 curves, and it's creating a radius, right? So the curves here are just straight edges, and then this is creating the fillet. Well, I gave it the fillet here. I did not flatten this input. So you see, this is input. This input is flattened, and this one is not flattened. So it's multiplying 351 by 351, and that's why it's giving me that big a number. So I actually want to flatten these radius inputs. And I think that should solve my problem here. 351, 351, that's great. So what I want to do is I want to kind of structure this data in such a way so that I can export it out to what they call a Grasshopper data file, and then read that data file into another Grasshopper script. So the component we're looking for is under params, utility, and we're looking for data output. And you can zoom in on here and click and, you know, create more inputs for this output data file. So the three outputs that I'm going to need, it's going to be my section profile curve. The next one is going to be my control point. And then this third one is going to be section profile label. So those are the three data inputs that we need. Now we need to go collect them because they exist here somewhere. So we know that the first one, section profile curve, is all coming out of this one right here. So all I need to do is go get a data component, feed that into here, put it in a group, right click and label a group, and I'm going to call that section profile curve. And I can read the data, and it's all flattened and it's neatly organized. So now I need the section profile label. Well, that label is coming out of here. You see how I kind of created a preview of the label from here? All I have to do is make sure that the data that's coming into this tree component is really just flattened. So I'm going to take this and fork off this data by double clicking on the wire and plug that into here, and then right click on the group and label that to section profile label, not curve. I don't know if you all heard that background noise, but there's some stuff that goes on in this apartment building that is just wild, I'm telling you. All right, so we want to hover over this, and you see this data structure is a bit different. This has 351 branches. Each branch has a single item, and this has a single branch with 351 items. So all we really want to do is either flatten this one or graft that one, convert that one to 351 branches. And I think what we want to do is, well, let's hold on. I actually don't know exactly which one I would need. I think I have a feeling that it's going to be graphed, but we'll get to that in just a second. The other thing we want to do is a control point. So if we just bake one of these sections, I'm going to bake this section to Rhino and study it. So for structural steel, there's always 4 control points. Let's take that and do a bounded box, and let's hide the section. So the 4 control points is going to be top left, top center, top right, middle left, middle center or centroid, middle right, and bottom left, bottom center, and bottom right. So there's 9 control points per structural shape. And the reason they want to do it that way is so now this shape has 9 degrees of freedom in terms of geometric rotation. So I can rotate the shape about this point, and it will result in a different orientation of the shape. I can rotate it about that point. So let's turn on our shape and actually begin to rotate in it and see how that looks like. So I'm going to do a copy. So you see, if I rotate it about that point, this is how that shape looks like. But then if I rotate it about this point, the same degree, which is 45, that's how that shape looks like. So it's a completely different position and structural properties. So this is why we always want to kind of collect those 9 points or 9 control points and store them somewhere logically. All right, so to create those 9 control points, what I want to do is basically practice on just this one curve and then feed it the whole input. I'm going to essentially do what I did in Rhino, which found I'm going to try to find the bounding box around the shape using Grasshopper. So all I need to do is go to surface, tab, primitive, bounded box, and plug that into here. And now I have a bounded box around that shape. Now I can deconstruct this bounded box. There it is. It's giving me the face, the 4 edges, and the 4 corners. Let's plug that into here. Let's plug the actual join curve, and now I have the bounded boxes for all of them. So if I hover over here, you notice that it gives me 351. I know it says 350, but always remember that it always begins at 0. So it's actually 351 branches. So this is telling me that there's 351 branches. Each branch has 4 edges, which makes sense because each branch is a single face. Each face is 4 edges. Okay, so what I want to do now is list out each edge independently. I'm going to go to Sets, List Item, plug that into here. See, this is listing item at index 0 is listing the bottom edge. If I zoom in here and maximize my output, item at index 1 is the right edge, item at index 2 is the top edge, and item at index 3 is the left edge. Now to get the control points for those, it's pretty straightforward. I think we've covered that at some point. We'll go to Curve, Analysis, Endpoints. And I want to get the endpoints of just the bottom and the top, right? So this is the bottom. I'm going to copy and paste that, and that's the top. Now what I want to do is find the middle points of all of those. So let's go to Curve, Analysis, Point on Curve. And if I plug the top point into this, it'll give me the center. So to help me organize all of this, because it's going to get confusing really quickly, I can hover over this, group it, create a group, and label it. And this is going to be my bottom center. Going to create another one. So this is my top center. And I'm going to go through and create the same thing for the 2 sides. So this is my right center. And this one is going to be my left center. All right. So now what we want to do is get a set tree, merge tree component. We want to start to merge all these branches. Let's preview what's inside each output of these points so that we can understand what is our data tree doing. And I also got a utility tree viewer or tree param component, param viewer, so that I can preview the data that's being collected inside this tree or list merge component. All right, so if I hover over this output start point, I can see that it's given me, again, 351 branches, a single item in each branch. Wonder what it's doing here. It's the same thing. So 351 branches, a single item in each branch. And so far, that's the correct data structure. So what I want to do is right-click on these inputs for my merge component and just switch the input to simplify so that I can simplify all the tree structure down to just a single path. And I think I'm going to need a total of 9 here because I have 9 points to collect. And I have no idea why Grasshopper did not decide to start this with D0 instead of D1. That doesn't make sense to me. All right, so we said that the first point is going to be top left, right? So these are my bottom points. And this is my top points. Yeah, I don't know how I did that just now. That was a cool trick. I'm gonna have to learn that one. So this is my top points. Now I need to know which one is my start and finish. And the way I do that is I just plug that in here and I know that this is my, that start point is actually my right point. So the first point in D1 should be the end point there. Then I need my top center. And you see how the data here is being collected. You see it just went from N1 to N2. It's because all these branches are structured exactly the same thing. So what it's doing is creating a branch for every section profile, and it's storing in that branch the associated control points. This is why we want to kind of structure the data in that way. So D1 is going to be the top left point, which is this one. D2 is going to be top center. D3 is going to be top right, which is that one. And then we're going to need left center. So that's this one. And then we need the centroid, and we have not found the centroid. And to find that, we want to go get a area component and plug the faces output of our bounded face component, bounded box component into the input of the area component, and that should give us the centroid here. So we can plug that into D5. You see, notice that the numbers here, number of indexes per branch is increasing as we plug more to it. So this is going to be centroid. I think I spell centroid. Yeah, there we go. So then we need the right center. And now we need bottom left, which is this bottom start point. And then we need bottom center, and then bottom right. There should be 9 points per branch. Let's zoom in and delete that last branch there. And now that should do it. So this is why I said we have to actually graft the components. So all these inputs here have to be grafted so that, let's graft and simplify them as well. So now you see branch 0 has 1 item that's for my curve, and branch 0 here has 9 items that's for my control points, and branch 0 here has 1 item that's for my label. That's weird not being able to like communicate with you all directly. Just anyhow, so I'm going to plug my sectional profile curve into my sectional profile curve input in my data output component, section label into my label here, and then control points right there. I'm going to right click on this and say destination. And I'm going to navigate to my destination, and I'm going to create a folder with today's date on it. So that'll be May 4th, 2020. and I'm going to call that data files. So May 4th, 2020, this is going to be my wide flange data. You see it's a .gh data file. That's what it's storing it as. So now I have this file stored. Let's save it. And now we want to go back to our original script with all the structure and read that Grasshopper data file into this file. So go to params, utility, and data input. Right click here and say source. And this is the file that I want to receive, and there goes my components. Right, so if I want to select a specific label here, let's see. So here's all my labels, right? And I know they're stored at 0 to 350. So I could easily just get a slider here that goes from 0, starts at 1, and up to 350. And let's see, I want to go get a sets tree branch component, and I can just plug all of my, You see it's given me the closed planar curve, the 9 control points, and the section profile. And here it is. So I could flip this all the way through and it will switch for every single possible shape. All right, so we know that the data is structured correctly and it's being read into this file. So what I want to do now is I want to take these lines, and I'm going to start out with columns because it's simplest, and basically extrude a specific section profile along each curve. All right, so what do I need? I have, let's just start out with the base columns, like this is the bottom floor columns. First of all, if I want to, let's just bake this actually. So I have my curves here, and just imagine that you're not using, for a second, you're not using Grasshopper. How would I go about extruding some sort of random geometric shape, whether it's a square, a circle, an ellipse, whatever it is, right? Well, first of all, I would need to move that shape from the center of that shape to the bottom point of the column, right? And then if I want to sweep it, I can sweep a shape along one axis. It says select rail. I select the rail, and then it says select cross-section curves. That's the cross-section curves. Enter again, and it's just swept the shape or extruded the shape along that curve. It's that simple. So we're essentially repeating that same process in Grasshopper. And for right now, we're going to repeat it for just a single shape. And then if we have time, we'll explore how to extrude different shapes at different column intersections. All right, so let's see, what's the first section label? So here are my section labels. One thing I could do is I could search this branch index by typing in a section label, right? So let's get a component here, plug that into here, and let's flatten that. Right, so I know that whatever index value in this single line item tree or list, it corresponds to the branch value of the main one, because this is how I structured that data. I structured it like that neatly. So what I could do is just filter this list and say, give me a W36 by 652, and I want you to look up the number 100. I don't want to type that in manually. What I want to type in is the section profile name. So I think I'm pretty sure we did that. I can't forget between this class or the other. We want to get a sets member index component. And the set that I'm searching is the set that I just flattened. And then I want to get a panel. And I can type in W36 by 652. That's a heavy, heavy shape. And that should give me index number 100. So what I could do there with that number is go get a tree branch component. And I could extract the tree branches, right? So now it just gave me that tree branch. And by the way, the reason that this is way out of scale is because we forgot to scale down. We have to scale down all these, the geometry by 12. Here we're in feet, and I think the other one we're in feet, and this is what's throwing us off. We'll worry about the scaling down here in a bit, but it's just a scale issue. It's no big deal. So I could even plug it into here, and it'll give me that same section profile. It'll give me all those points that are associated with that. So I know that's working. So let's just use that as our starting point. I think I might have to actually scale this down right now. So I'm going to go back to my white flange. Let's see how we're going to scale this thing down. I think under transform Euclidean, maybe. Affine scale. So the geometry on the scale is here. Center of scaling is going to be centroid. Factor of scaling. God, I forgot what the factor here. What is the factor? Let me see. I wonder what happens if I switch these units to feet or inches, sorry. If I go back. I see. Yeah, we're not going to be able to do that. We're going to have to scale it down. I think that's correct. Now, after you plug that, I typed in here 0.083 because I divided 1 by 12, and I think that's the scale factor. At least I'm fairly certain right now. I could be wrong later. We'll see. Yeah, that looks about right. So then I moved all of these inputs here. Actually, let's just repeat this process by explaining affine, scale. I think there's scale non-uniform, or this is scale uniformly on dimensions, and I think that's the scale component that we need. So first of all, before I plug that into here, I want to move all of these wherever this component is being plugged into. I want to move it to the output of the scale component. So you can hold down Control Shift, and you can move whatever is plugged into that one into the other one. Then plug that here, and then right-click on Factor, and put in 0.083. I mean, and you could be really, really precise and go up to 1 divided by 12 is 0.0833333, and that will give you, of course, the more number threes you put in, the more accurate you are. And there it is. So now to update this data file, all you have to do is right-click your wheel mouse, and then click on play, and that should recompute the script and update that Grasshopper data file. This is why it's taking a bit, I think. Let's go back to that Grasshopper data file, and then let's recompute here so that they could read in the right information. And there it is. So now I think we're good. So if we did everything correctly, let's see, let's do distance. And that's 15 feet, and that should be 3 feet. Or 3.4 feet, this is correct. The W36 by 652 is pounds per linear foot. There's no way you'll actually get a 36-inch deep, exactly 36-inch deep, that weighs 652 pounds per linear foot. Just, you can't, you have to kind of beef it up. So W36 is actually an approximation, not an exact number. Anyhow, so what we want to do now, so we have the shape. We want to extrude that shape at every base column. Okay, so first let's go to surface. free form, and there's a couple things we could do. We could do sweep, create a sweep surface with one rail curve. So the rail curve is going to be my bottom. The section curves is going to be this shape. So what I want to do, it's only creating, well, it's actually creating 15 columns, but all in the same position. And the reason that it's doing that is because it doesn't know how to position the center of the shape along the center point of each column relative to where it's positioned in space. So what we want to do is find that center point and place that shape along that center point. So let's go to curve endpoints, and let's get that. And our start point should be the bottom of the column, at least if we did it correctly. Yeah, of course it's not. Oh, yeah, no, start point. There it is. Okay, sweet. So the start point is the bottom of the column. What I want to do now is basically apply a shape at the base of each column. So I want to go to transform, Euclidean, sorry, not Euclidean. Nope, yeah, it is Orient. So the geometry that I want to orient is the shape that I have selected. The initial plane is going to be your origin XYZ because the shape is at the origin XYZ. And the orientation or final plane is going to be the start point of each column. You'll see it's placed a section profile at each endpoint. Now I can take that and plug it into the section profile, and it should extrude a column at each endpoint. So let's select everything and turn off the preview, turn on our permanent preview, and let's just turn on the sweep, and there goes our column. Actually, I also want to turn on all of my framework. So there it is. Like this is awesome. At least I think it is. What can I do with this? So I can control my initial plane instead of just feeding it the default XY plane. What I could do is go to vector, plane, XY plane, and place an XY plane at each start point of the column frame line. And then what I could do with that plane is rotate it. I can rotate plane. I can right click on the rotation and say, I want this in degrees. I can click on my canvas and say, I want a slider that goes from 0, that stops at 90 and goes up to 180, right? I can plug that into here, and you see now, let's hide this preview. You see now this plane is changing. So I could plug that into here. You see that now based on my rotation, my columns could rotate. So I could say, I want all these columns to be 90 that way or 180. And they could switch however you want them. It's pretty awesome. This is, for you all that have used Revit, this is essentially the Revit rotation parameter that's built into the column instance profile. All right, so we could essentially, what could we do here? We could cluster this and repeat that for every level. I think instead of doing that, let's just move on to extruding some sort of beams. Beams are going to be slightly different. Let's do the girders, I think, first. Let's do girders. So we want our columns to actually orient 90 degrees that way. There we go. And then we want our girders to sweep from this column to that column. All right, so this time for the girder, I want a slightly different shape. How's that? Let's see. I'm going to take a W24-207. How's that? W24/207. There goes my shape. Yep, there it is. Now what I want to do is basically get the start point of every girder. So this is going to be the same process again. Those are my start points, right? And I want to extrude these along the x-axis, which means the plane of my extrusion is going to be the YZ axis. If this is confusing a bit, I would recommend that you just kind of try to visualize the Cartesian principles that are guiding all of this stuff. So this is my YZ plane. I'm going to take my start point and apply it to my YZ plane. I should get a plane at the start point of every girder, like so. And now I'm going to do the same thing with sweep and extrude. I'm sorry, sweep and orient planes. So the geometry, the geometry on orient is my new curve, my new section profile. And the initial plane is my XY plane, and I want to orient it to this YZ plane. And this is thrown in error because it's the long curve. It's the wrong curve. Oh, it's still thrown in error. Wow, that is radical. Whoa, something happened that was wrong here. So this is one. So you see there's something wrong. I don't know why it's giving me 173, 174, 175. Let's try to figure out why it's doing that. It's really strange. By the way, I can't, if you all are asking questions, you're gonna have to unmute your mic because I don't know where my chat box is. Let's see, what's the error here? Sweep could not be created. Well, that's not helpful. I wonder why that is. I think we have to graft both of these inputs. There it is. I think this thing only needs one input, one branch per one section profile. And unlike our columns, see, our columns were already stored by our initial data structure with one branch containing one column frame. And here it's not the case. Here it was one branch containing 4 girders, which is along the grid line. So now we have our columns, we have our girders, and now we want to create our beams. So let's move on to beams. We also want to start like grouping these in so that we won't get lost. Columns. Girders. All right, so let's experiment with these beams. Let's see, I think this is going to be very much similar to this. So let's copy this whole thing. And let's relabel that to beams. And the input here is going to be that one this time. And the input here is that one. There it is. So this is, I think, a bit cool. Now, I think what's even better than that is finding a way to apply a unique index to all the columns, girders, and beams. Export that unique index to an Excel spreadsheet. And inside that spreadsheet, we could add inputs. We can add the section profile and have it search for that section profile in the Grasshopper script. We could add, let's see, what else we could add? We could add a cross-sectional rotation. Let's just tell you what, let's just do that. Section profile and cross-sectional rotation. And if we have time, maybe we could add a bit more customization to that one. So we want to structure this data so that it exports out in a logical manner, right? Like, so every item here is being stored in a branch for the columns, but not so for the girders and the beams. So what we want to do is basically right-click and graph these. I think that's the way to do it. So graph them. I'll likely change my mind here in a few minutes, but we'll see how that goes. Okay. So what we want to do is go to Lunchbox, workflow, and say Excel write. So let's do params tab, input Boolean toggle, and plug that into write and clear. Actually, let's unplug it from clear and let's just do another Boolean toggle there. That clear there, if it's such is true, that means we'll overwrite that file every single time this toggle here turns it true. So for just safekeeping, let's do 2 separate toggles. And under the path, we want to complete path. So let's go back to our folder, file and folder location. And, that's not it. So I created this folder today, and what I want to do is right-click and say, I want to create an Excel spreadsheet, and I'm going to call this 0504-2020, and this is going to be my structured database. So under my path here, I can just simply select the path, copy it, add another backslash or forward slash. I always forget which was which. Right click on here and copy the whole file name. There it is. For worksheet, we're going to keep it default, sheet 1. And then the headings, that's the header for each column. So we're going to have 3, a unique index per frame, a section profile, and a cross-sectional rotation. So we're going to switch this panel to a multi-line item, and we're going to say this is index. Section profile and cross-sectional rotation. And let's plug that into headers or headings. And now the data, we want to basically store all that data into 3 separate lists or branches. So let's see. For right now, let's just switch this to true. And let's go and open that file and see what's in it. Did it write anything? I always like to test out to see if things are being read. Is this open somewhere? Oh, that's underwhelming. All right, so let's see, 1, 2, 3. Multiple lines, put that into data. Something's happening. It increased to 9 kilobytes. So let's open it now and see what's in it. All right, so we at least know that it's reading something. That's promising. I wonder why it's not reading the 1, 2, and 3. So let's set this to false, set this to true, and right-click on data and graft it. And let's rewrite it. Yep, there we go. There we go. So it happened now. So this is telling me that it needs the rows to be stored individually in a separate branch. All right. Switch these to false. And let's exit out of our Excel. All right, so we're gonna actually have to flatten all these, but we need to flatten them in order. So let's get this, so I'm gonna plug level 1, 2, level 1, 2, and 3. By the way, I got an entwined component here. Right click and simplify. It should say 0, 1, 2, each one has 15 items. Okay. So let's do that for this other one, my girders, level 1, 2, and 3. Simplify, each one has 12 items. And let's do that. And by the way, this should say flatten. Flatten inputs here should be checked. Level 1, 2, and 3. And that also has 3 inputs. All right. So now I want to create a unique index for each item. Let's see. Since I know that these are columns, I'm going to call those COL, short for column. Let's copy that and put in GRD, short for girder. And let's copy that and put it right underneath this one and call that BEM, short for beams. All right, so we want to just basically generate a unique number for each list. And I also know that each list has a separate level, right? So that 0 is level 1, 1 is level 2, and so on. Let's see. So let's go to set sequence series. And I want to generate a series of numbers that start at 1 and end at that number of branches, right? So I have 3 branches here. So I want to go get a tree statistics. This is under tree statistics. And this is telling me that it has 3 branches, and I can plug that into my count. And I should get a series of numbers that start at 1 and end at 3. So now I can go to text and get a concatenate component, and I can concatenate the letter L. Concatenate, it basically means string together or stitch together. So the letter L for level with the numbers here, and that should give me, if I hover over L1, L2, L3. Now I need to generate a series of numbers for each indexed item. You see what says n equals 10? I need to generate a series of numbers that goes, you know, number 1, 2, 3, 4, 5, all the way to 10. So I need to get the list length here. Actually, I already have it here. It says 10 items. Let's generate another series of numbers here. So this is going to go from 1 to 10. Let's right click and simplify. You see here, it's going to 1 to 10. And now I can concatenate my abbreviation here with a separator of underscore with my numbers. You see it says L1. Whoa, this is not, I need to graph these. There it is. So my first branch is storing all my L1s and each unique item. My second branch is storing my level 2 indexes, and my third branch is storing my level 3 indexes. And now I could further concatenate the BM suffix to it. And now this is telling me that this is a beam at level 1 at position 1, whatever position 1 is. So I essentially want to repeat this process for all the other 3. Simplify. Okay, so let's repeat this process. Actually, we want to not simplify this. We want to flatten it, not that we've guaranteed that it's in the right structure. So let's take this here. The tree statistics I want to read is that. the girder is that one, and that should be right. Let's repeat that one more time for the column. 15 columns, and that's also correct. So now I have my 3 branches. So all I need to do is get another entwine component and plug that into here. See, I have 3 branches. So that's my unique index. So my unique index is going to be storing just the index value, and the section profile and the cross-sectional rotation is going to be an input that I put in the Grasshopper. So for here, I'm not going to feed it anything. Let's see, what we want to do now is actually further right-click and flatten this one, and let's get another branch. And I'm going to type in open quotation marks and close quotation marks. That's for an empty data input. Open, close, plug that into here, and now I should get 3 branches. One that has 111, and the other ones has 1 and 1 because it's just an empty space. Right-click and simplify, and plug that into data. And don't graph this one right now because the stream is already grafted in the original input. Oh boy, this is starting to get messy, so let's push this aside. All right, so I think we're ready. Let's switch this clear to true, and let's switch this toggle to true as well. Before that, I'm going to save. There it is. There we go. Feels about right. Oh man, I don't think anything happened. Something went wrong. This is 8 kilobytes. It's not correct. Yeah, something went wrong. Huh. I wonder what went wrong. You know what? I think I know what went wrong. Let's plug that back into data. I think what went wrong is the number of branches is not correct. Oh, I'm sorry, number of items inside each branch is not correct. So what we want to do is repeat data. We want to go to sequence, get a repeat data component. And the data that I want to repeat is going to be just an empty string, open quote, close quotes. That's the data I want to repeat. And the number of items that I want to repeat it is really the length of the output of this component. So I'm going to go to sets, list, length. You see now this is generating 111 open quotes, close quotes, and I'm going to plug that into here. Now let's switch this to true and see what happens. I think that's the problem. Oh, 11 kilobytes is still not promising. Hey, look at that, it worked. Sweet. Now, what I really want to do is not even have open or close quotes, like literally. What I want to do is just, I want to get an empty cell. So let's try to see if we could do that. I'm pretty sure there's a way around it. Switch this to false. Let's just delete this, see what happens. Okay. Switch this true and see what happens. It's down to 10, so that's promising, I think. Took out 1 kilobyte, so eliminating all those open and close quotes. There it is. All right, so now this is kind of cool, right? It generated an Excel spreadsheet with every column, beam, and girder uniquely indexed. But what's not cool is that I can't really filter. I can't filter the beams from the columns from the girders, level 1 from level 2, and so on. So let's try to see if we could filter. Well, let's try to see if we can structure the data in such a way where we could actually utilize Excel filters. So first of all, let's again switch this to true. And what I want to do is underneath after index, I want to create type column, and I also want to create a level column. So now I'm going to get the index here, and I'm just simply going to split that. And I know that the first item on my index is the type, and the second is the level. So I'm going to connect that to split, and then I'm going to split it based on this separator here. And that should give me 111 branches. Each branch has 3 items, which is correct. It's going to be the type, the level, and then the unique ID for each element. And all I want to do is extract items at index 0 and 1. So let's go to sets, list item, and then plug that into here and extract 0 and 1. So that's 0 and that's 1. All right, so what I want to do now is add 2 branches here because I added them between my headers 1 and 2. And then I'm going to just simply plug those into here. I think that should do it. Yep. Let's switch this to true. That should rewrite our table. Save it. Let's go to our table. Man, only 1 kilobyte, all that? It worked. So to filter through now, we can just select one. Why am I not seeing? We can just select that top row, the headers, and go to sort and filter and just say filter. And what Excel will do is give you a unique identifier here of all these. So it'll basically give you the unique values, and you can just deselect all and say select columns, and here is just the columns. You can do the same thing for the levels. You could just select columns of levels 1. So now this is where we can type in a section profile, right? So we could say the columns of level 1 are going to be a, let's see, let's get a section profile. Where are we? We want right here. So columns at level 1, we want them to be a W, I don't know, a W 18 by 65. All right. So W18, all caps, W18 by 65. And if you hover over that small square at the bottom right corner and double click it, it should just copy them all the way down. So now I want to edit the columns at level 2. And I want the columns at level 2 to be a W14 by 48. I'm just completely guessing here. 14 by 48. You could do whatever you want, whatever you please. And then I want the columns at level 3 to be yet smaller than that. Let's do 1240. W12 by 40. So this is all of my columns. Now I'm going to uncheck columns and select girders. And my girders, I'm just going to keep it simple here and just pick one section. And I'm going to do a W1287. Before that, I want to actually select all 3 levels to preview all my W12 by 87. And for my beams, I want them to be even smaller than my girders. And I'm going to do a W10 by 30. So beams, select beams. W10 by 30 and double click that small box there. And then now I'm going to save this as my structured database edited. Just in case I overwrite it from my Grasshopper, I won't lose this data that I just inputted in. All right, so now we have the structures database edited. Let's actually take all this work that we did and move it up top. And let's just copy this down. Just move this work away from our preview. And then we want to select all of these, group them, right click and say, this is export in structure database. All right. All right, so now we have to read that database that we just created. So go to Lunchbox, Workflow, Excel, Reader. We want a Boolean value here. We want a file path, go to primitive, file, file path, right click, set one file. And let's click that edited. And the worksheet by default is going to be worksheet 1. And under data, we should have, well, switch this to true. That'll help. And we should have all that data coming in out of Grasshopper. I'm sorry, the Excel file. So we should have 5 branches, like the branches we exported out. Each one has 112 items. We never really inputted anything for this cross-sectional rotation, but we'll get to that. So now what we want to do is basically call out the first index of every branch, because the first index of every branch is the column header from Excel. So we want to go to sets, sequence, index. By default is nothing, so we want to right click, set the integer 0. And then plug the data output into the list input of the col index. And there it is. So now this is exactly how we want it. Simplify, okay. So we know that however this data was structured, right? We already structured this data accordingly. All we have to do is get this component right here and plug the outputs of these branches in the same exact order. Yep, columns, girders, beams. So now this has the same exact order of components as these. These are the curves we want to use now because this data now has been restructured. So I know that the first curve here is has this unique index at beam level 1, 1, right? And we could double check that. We could just say, list the first item of this and let's see where it goes. And that looks like about level 1. I did not really worry about where the number 1 starts. It just automatically figured that it'll start there. But that looks right to me. Okay, so we want to split this data tree here into its separate components, separate tree branches. So we want to go to tree, explode tree, and that's this component, and plug the output of the Excel data into it. And notice it's in orange. If you right click and say runtime warnings, it says tree contains more branches and this component has output parameters. Well, all we have to do there is zoom in and give it more output parameters until it goes from orange to this grayish color, which is not throwing any errors. So I know that branch 1 is my unique index. I'm not going to use that. Branch 2 is going to be my unique identifier. Branch 3 is which level it's on. Branch 2 is which level it's on. And then branch stored at label 3 or path 3 is my section profile. Well, what I need to do now is search for that section profile inside here, right? So let's do params, primitive, data, section profiles, plug that into here and flatten that one. And now I could do member index. The set that I'm searching is the output of my data input. And the members that I'm searching is this one. And this should give me a set of numbers. That's about right. Right. I put in about, I don't know, 4 different fact numbers, something like that. 321 at each branch. That's correct. All right. So now what I could do is use simplify. That goes down to that branch. Is that correct? No, sorry. We don't simplify. We want to flatten. And now we want to go get a tree branch. And the tree branch that we want to filter out is the section profile curve. And the branches, it's going to be these. That's about right, right? We had like 4 different sections or 5 different sections. 1, 2, 3, 4, 5. Yep. 3 for the columns and then 2 for the beams and girders. I'm not really sure. I can't remember. All right. So now we have all of our section profiles, which is good news. Now we want to take all these section profiles from one index to another and place them at the right right endpoints to extrude them. Oh boy, let's figure this out together. I haven't done this in a while. So if I get a curve, endpoints, list out the endpoints, have all my endpoints. Let's unflatten this one. So I know that my first branch is my beams, second is my girders, and the third is my columns. There we go. Let's also, I want to also explode this tree. So this is the start and end point of my columns, and I want to place a XY, XY plane at the start point, and that's correct, right? Yep, that's correct. And then I want to place, let's copy and paste this one. And this is going to be our girders, and I want to place a YZ plane at the start point of my girders. And I'm pretty sure that's correct. Yep. Now for my beams, I want to place a XZ plane. Excuse me. XZ plane. Select all the beams. And that's correct. All right, sweet. We're almost done. All right, so now we want to recombine these planes so it matches this data structure. Well, I think that's easy. We need an entwined component and just combine them in order. There it is. Same data structure. What happens if I flatten this one? Flatten that 111, 111. All right. So now I want to get a transform Euclidean orient. The geometry that I want to orient is going to be that one. And it's going to orient to my world XY plane, which is correct, to that plane. Uh-oh. So it's orienting, oh, maybe this is correct. We'll see. Let's extrude them and see what happens. So let's go to surface, freeform, sweep 1. The rail, I want to flatten this one. Yikes. I think I might have crashed it. We'll see. should have saved. Let me save. So actually, instead of flattening, I think I needed to graft. I also need to grab that one. Oh, it worked. Let's bake it. Deselect. Let's go here and make this 25. Right click and do Arctic. And now we have a wild structural frame. Now you can imagine that you can make these wireframes be whatever you want. It could be a Zaha Hadid, completely parametric curve. You could, I mean, the options are pretty much endless. It really is about your computer processing. But yeah, here it is. So let's do a little bit of an experiment now. And let's add a section profile. Let's do 45, 45, 20. You know what? Let's do something a bit more logical. Let's filter out. So let's do columns. And we want the columns at level 1 to be 45. And at level 3 to be 45. Let's just save it. Let's delete all of this that we did early on. So if I click here, it should recompute. Oh no, it's not going to rotate it because I'm not actually reading the rotation just yet. So what I want to do to actually read the rotation is I have to program it in to read the rotation, and I haven't done that yet. So remember earlier with the plane, before we projected the geometry, we had it rotate the final plane. So if we wanted to rotate the final plane, we want to go to vector, plane, rotate plane. The plane we're rotating is that one. And the angle of the plane, well, it's the data from here, right? So most of them, it's empty, except for the columns, which just say 45 every other one. That's correct. Now, empty is going to throw an error here because there is no such thing as an empty angle. I mean, the smallest angle is 0, and the largest is, I don't know, 360, whatever it is. So we want to kind of convert an empty to a 0, essentially. So let's see how can we do that. Let's type in empty. Is there something empty? No. Okay, let's see. Let's do an expression. I'm going to type in if x is equal to open close quotes, then give me 0, else give me x. I don't want this x value here, and let's do that. Let's see if that worked. Oh, it did work. Man, that's awesome. I'm going to right click here and say degrees and plug that into here. So now these rotations are the correct rotations, and plug that into here. There it is. Our columns rotated the first level and the top level. And you can do the same thing with the beams and girders. So that's all I have for you, everyone. What I need you to do for the assignment is basically do exactly what we did in this script. Now, in this script, we've only read in the white flange data. You can create the same exact, so part of the assignment is creating the same exact output an input component here with your hollow structural section script. Again, it's just three properties, the curve, label, and control point. And it's the same exact script that we used in the white flange. As far as I'm concerned, once you do it here, you can just literally copy this, excuse me, and paste it into a hollow structural script. And then I want you to read that. Come on, where are you? I want you to feed that into your structure sweep script and just use it. I think that is all I have for you for today. Do we have any questions? You can turn back on your camera, your mic. Let's try to engage each other here for a few minutes. I can't believe I've been talking for like almost an hour, over an hour. No comments? No questions? Can you all hear me?
Yeah, we're good.
Yes.
Okay.
Yes.
All right, sweet. Oh, thank God. I was like, oh man, I just spoke for an hour and nobody heard me. All right, everyone. Well, this is all I have. Does this make sense?
Yeah, are you going to email us the video?
Yeah, I will.
Great, thank you.
All right. Well, if there are no questions, till next time, everyone. All right, take care. Bye-bye.
Thank you. Bye.
Thank
Good
you.
one.
Yep, bye-bye.
Thanks, bye.
Bye-bye.